This is my new dry centrifugal pump. I developed this pump to make reverse osmosis, water desalination, much lower cost, and also to make pumped hydro storage more efficient. This pump is really for large scale, high volume, 24/7 operation. It's really not for small applications. So the parts in the system include the compressor, the air release valve, the controller, and 3 liquid level sensors. And inside the housing, you've got the generator, the turbine, the closed trapped impeller, water inlet, and the variable frequency drive motor. Now, before I show you the startup operations for this pump, which are very similar to a standard centrifugal pump, you might wonder why there's a generator in here. Well, the dry centrifugal pump is made possible by this closed and trapped impeller. Without this impeller, you couldn't have a dry centrifugal pump. And without this little reservoir around the wear ring, you also couldn't have a dry centrifugal pump. So these 2 blue lines represent little troughs that bring a percentage of the pumped water into the trough around the wear ring, which prevents air from passing through the wear ring. So the startup procedure is a little bit different than a standard centrifugal pump. Like a normal pump, you need to prime it. So the Arduino or some kind of controller would bring the water level up to a point above the closed trapped impeller. Then you could start the motor at a slow RPM, somewhere around 500 RPM. And then the controller will lower the water level down to someplace between these 2 points. Once you do that, you can run the pump at full speed. This is the prototype of the closed and trapped impeller. You can see I've greatly extended the suction eye, but that's just for demonstration purposes. It's not easy to see the trap on this prototype, so if you click on the link below, you can see the test of this prototype. I also show with a cross section how it works.